Centroids. What are centroids? Centroids. We could talk about centroids and center of gravity. Center. It has the word in it. So centroids are the center of gravity of objects, as you can see here, or the center of mass. It's denoted by the BMW symbol. It's denoted by that. So wherever you find the center of gravity, you'll draw that little symbol. So in physics and in engineering, when an object has a weight, like acceleration due to gravity, that's the weight of an object. We're gonna consider it applied at the point at the center of gravity. So we'll consider the acceleration due to gravity, so the force that'll be applied directly to the centroid. The object is in a state of equilibrium if it's balanced, and that will happen along its centroid. If you're not balancing it on its centroid, then it won't be balanced. This guy has a strong finger. He could hold the 25 pounds with just one finger. Wow, he must work out his fingers. Okay. An object centroid location in statics is used for theoretical calculations regarding the interaction of forces and members. Okay, yeah. That we'll use that if there's a couple different forces acting on an object, we'll think of it as acting on the centroid. Yeah, that's pretty much what that means. Moving right along. So we'll have three-dimensional objects, but if they're symmetrical about the x, y, and z axis, to determine where the centroid is, say like this I-beam, for instance, this I-beam, it's symmetrical if you turned it and then just looked at it from a lateral view. It would be symmetrical so that the centroid would be like cut down in the center, and so we can just actually look at the cross section of the three-dimensional object and find the centroid of this, because really we already know that the centroid is going to be halfway in between the edges of this I-beam, and so we could take the cross-sectional area and then find the centroid here. How do we find the centroid? It's different for different types of objects. The centroid location for a triangle, that you use geometry for that. It's actually called finding the centroid. There's a method to do that. We'll be looking at right triangles though. Centroid for a square. Hopefully that makes sense. It's on the lines of symmetry. If there are multiple lines of symmetry, it's on the intersection of those lines of symmetry. So centroid location is determined by the object's lines of symmetry. Okay, yes, let's move on. I think this part is intuitive. The centroid location of a square is just half of the length and half of the width. And there you go. It's right in the middle. Smack dab in the middle. So it's the base divided by 2 and the height divided by 2. That's all it's saying. X bar is going to be the center of those axes. So Y bar will just be the center of the Y side. X bar will be the center of the X side. And then you put them together and you get the centroid. That's pretty easy. You just measure the whole thing, cut it in half. Measure the whole thing, cut it in half. It's the same for rectangles. Yeah, that's it. Oh, I don't know if I was recording. Oh, hopefully I was recording. I don't know. I was recording. Just kidding. Sorry. Alright, so the centroid location of a right triangle, that one's a little bit weird, but X bar, it's just a third of the way down from the reference axis, and the reference axis will usually just make the left and bottom of the shape. So, yeah, the centroid of a right triangle is located at the 1/3 of its height and 1/3 of its base. So you measure this whole distance, and then you divide it by 3, and that's how you get Y bar. You measure this distance, and then you divide it by 3, and that's how you get X bar. And then you put them together, and that's where the centroid is. It's the intersection of those lines. Centroid location of a semicircle. Well, semicircle, it's located at 4 times the radius, but divided by 3 pi. It's a weird one. So that means on this particular semicircle, if we have a radius of 2 inches, then we have to do some calculations. So, note that the centroid is going to be definitely in the middle that way. I just don't know. I don't know how far, like up or down. That's what I'm calculating. So I already know that it's going to be on its axis of symmetry here, but I can't tell its axis of symmetry. Like it doesn't have an axis of symmetry because it's not symmetrical laterally or vertically. I don't know. So the centroid would be 4 times r, so 4 times 2 inches, and divided by 3 pi. And as a decimal, that would be, what, 8 divided by 3 pi. That'd be around 849, almost 8.5, 849 inches. So if this whole thing is 2 inches, and we have 0.849, then it'd be maybe up that much. I don't know if that's a guess. I'd have to measure it. So we'd have that. And there we go. That's how you do that. That's pretty simple. Now we're going to look at, I think, our first example maybe? Or look at our formulas. So for complex shapes, that means there's more than one type of shape. So maybe you'll have a triangle connected to like a couple squares connected to a semicircle. We're going to be able to find the centroid of like weird looking shapes. And I'll probably save that for the next video.